Assalamualaikum and welcome to the video. I am Aziman bin Abu Bakar here from Physics Unit KMPK. In this video, we are going to go through experiment 5, friction. What we hope you to get from this video is that you can appreciate the important the practical session in facilitating your learning of physics, hence making the learning meaningful. Because some of the apparatus might be foreign for you, we introduce them in the video. Reading the procedure with no background knowledge could be confusing and intimidating, so we go through the setup process for you and we hope the procedure will make more sense to you. We are not going through the procedure step by step, but rather we are giving you the overview of the experiment and great tips to help you with the experiment. Make sure you have with you the lab manual and open them to page 18 on the experiment of friction. And also you are going to need your jotter to jot down important information and tips as you go along with the video. Before going to the lab session, make sure you have the objective, a brief summary of the procedure, and table for data collection ready in the jotter. You can also add sketches as a visual tool to help you with the procedure. It does not need to be perfect or beautiful, just keep it loose. In this experiment, we are going to utilize the concept of static and dynamic equilibrium to determine the coefficient of static friction and kinetic friction. In both cases, the sum of the force is 0. Based on the figure given, every object that have contact between surface will have friction. And we have two types of friction, that is static friction for object at rest and kinetic friction for moving object. In the static friction, we are going to determine the value of coefficient of static friction and the symbol is μs. Another one is kinetic friction and we are going to determine the value of coefficient of kinetic friction and the symbol is μk. Since kinetic frictional force is less than static frictional force, therefore coefficient of static friction is greater than coefficient of kinetic friction. Next, we will go to the graph. From the equation that we have established earlier, we can plot a graph of static frictional force Fs against normal reaction force R. If we compare the equation with a straight line equation, the static frictional force Fs will take the y-axis and x-axis for normal reaction force R, and the value of C is 0. The graph should start at 0 and the graph is going to be a straight line graph. When plotting your graph, make sure that the graph occupies at least 80% of the graph paper. Coming back to the straight line equation, the gradient of the graph will be equal to μs. Choose 2 points on the line and draw a right angle triangle connecting the 2 points. Make sure the size of the triangle at least 50% from the size of the graph. The gradient of the line can be calculated using the equation m equal to y2 minus y1 over x2 minus x1. And the value you get from the calculation will be equal to μs. Same goes here for kinetic friction. If we compare the equation with a straight line equation, the static frictional force Fk will take the y-axis and x-axis for normal reaction force R, and the value of C is 0. The graph should start at 0 and the graph is going to be a straight line graph. Remember again, when plotting your graph, make sure that the graph occupies at least 80% of the graph paper. Coming back to the straight line equation, the gradient of the graph will be equal to mu k. Choose 2 points on the line and draw a right angle triangle connecting the 2 points. Make sure the size of the triangle at least 50% from the size of the graph. The gradient of the line can be calculated using the equation m equal to y2 minus y1 over x2 minus x1. And the value you get from the calculation will be equal to mu k. You are going to compare the value obtained for mu k and mu s. Before we continue with the procedure, I want you to pause the video, open the manual and go to the procedure section of the experiment. After you have read through the manual, you can come back again to the video. If you have read the manual, these two statements will make a lot of sense. In the experiment, you are going to manipulate the rested slotted mass MR and then record the mass of hanging slotted mass MH for both static and kinetic friction. In data collection section for the static friction, weigh the mass of the wooden block and after that complete the table section. Same for data collection section for kinetic friction. Weigh the mass of wooden block, complete the table and make sure enter the uncertainty for your measurement. Let's go to the apparatus and setup. First of all, we are going to use a square plywood. We have a wooden block that have been embedded with hook. A plasticine as a stopper for the wooden plywood is used in the experiment. A string as a connector. We are using the pulley clamp to hold the string. We are using paper cup as a container to hold the slotted mass. We have sets of slotted mass and sand granules which have different mass, which is 2 grams, 5 grams, and 20 grams. And the sand granule mass will be measured by using the electronic balance. Tic-tac pen is used to produce a constant force on the wooden block. To prevent the plywood from sliding, we will attach 2 plasticine between the plywood and the table. Make sure the pulley is clamped in the middle of the plywood. The string should be tied up neatly to the paper cup and the another end to the hook of the wooden block. When the wooden block have been set on the plywood, we need to mark the starting position. Slotted mass need to be put gently into the paper cup to avoid impulsive force. And if the paper cup keep moving or rotating, hold the paper cup to prevent it from moving. The slotted mass or sand granules were added gradually until the block start to move. Weigh and record the total mass. Repeat the experiment by adding the slotted mass on the wooden block. For the second part of the experiment, we are going to use a tic-tac pen to exert a little push on the wooden block until it moves slowly and steadily along the plywood. If the wooden block doesn't move slowly and steadily, add the mass or sand granules until it starts to move steadily. Record the total mass. Repeat the experiment by adding the slotted mass on the wooden block.